Hi, so the question here is there are 13 grams of sodium chloride, 12.75 grams of lead chloride, 16.5 grams of strontium chloride added to a 1 liter volumetric flask. What is the concentration of chloride ions in the resulting solution? First thing we need to do is I just wrote out the information of this question out here, 13 grams sodium chloride, 12.75 grams of lead chloride, and 16.5 grams of strontium chloride. The reason there's one chloride on here and two chlorides on here is that chloride has a -1 ion, basically. And sodium, if you look at the periodic table, is in group 1. And because it's in group 1, it has a +1. Lead has a +2 as stated on the Roman numeral 2 here. That means it is a +2. And strontium here is on group 2. It's located in group 2, which means it is +2. That doesn't have to do with everything here. These groups are different, but for now, just know that group 1 and group 2 have +1, +2, and group 13 here has a +3. Chlorine, starting from 17, has -1, 16, group 16 is -2, and group 15 is -3. All right, so figure out the grams per mole. You can get this all from the periodic table, by the way. So for an example, sodium, you can look, sodium is here. It has a molar mass of 22.99. I just did the same thing for sodium, lead, and strontium. Chloride and chloride. Since these elements have two chlorides, I just multiplied the single chloride by 2 to get 70.9 gram per mole. Okay, so how do we figure out the concentration of only chloride? First of all, let's find the moles of each of these molecules first. So to do that, we just add these two numbers together for all of them. So let's just do that real quick. Just add everything here. Add. What you'll get is, let's go to my calculator. 58.44 grams per mole. And this would be 207.2 plus 70.9, 278.1 grams per mole. And for this one, 87.62 plus 70.9, 158.52 grams per mole. Okay, so we're trying to find the number of moles. So we're already given the initial amount of grams. What we can do is we can divide this number, or divide 13 grams by this number, and likewise 12.7 divided by this, 16.5 divided by this to get the total amount of moles. So I'll do this one real quick, and then we can do the rest. So here it's 13 grams over 58.44 grams per mole. And what you'll get is 0.222 moles. Oh, sorry if you can't see that. Give me a second. Yeah, okay. Yeah, 0.22 moles. If you do it for everything, again, 12.75 divided by 278.1, you will get 0.0458 moles. And for here, 16.5 divided by 158.52, you will get 0.1041 mole. Okay, so let's simplify that a little because these are pretty large numbers. So let's bring these all the way back here. So what we know is that there are 0.222 moles of sodium chloride. We know there are 0.046 moles of lead chloride. And we know there are 0.1041, or we'll just put 0.104 moles of strontium chloride. So how do we find the concentration of chloride ions, right? Ions. These are only the moles of the molecule. So what will happen is these will dissolve and split into their ions. And NaCl will split into Na plus and Cl negative. Lead chloride will split up into Pb and 2 chloride ions. So now that we know that, we can do this. So we know that this will only split into 1 chloride. So we don't have to do anything to that. So that'll be 0.222 mole of chloride ion. We know this splits into 2, so we have to multiply 2 chloride ions. So we have to multiply this by 2 to get 0.092 moles of chloride. Same with this. This also splits into 2, so we have to multiply this by 2. 0.208 moles of chloride. And when you add all of that together, you get 0.522 moles of chloride ions in total. Let me do a real quick check for a little bit. Yeah, so everything seems to check out here. So once you get the 0.522 moles of chloride, what you can do is, since it is added to a 1 liter volumetric flask, you already have it, 0.522 moles of chloride over 1 liter of solution equals a molarity of 0.522 molarity of chloride. And this will be your solution, or the 0.522 molarity.